Hey friends, yes, if you're thinking the same thing, I got a TXV and I'm gonna cut this part here that connects your sensing bulb, and I wanna see what do you hear. Are you hearing that? That's refrigerant coming out from the sensing bulb. Yes, the TXV, even though it's not installed right now on a system, this part here has refrigerant and I can still hear it leaking. I'm gonna try to put it back on the mic. Now, of course, rest in peace, TXV. I did happen to have an extra one, but I did it to show you that this part here has refrigerant. Now, of course, you're not going to be going to your service calls and cutting them to make sure to see if there's no more refrigerant, but I'm going to show you two ways to check if the sensing bulb has lost its charge. Okay, so before we go into the package unit and show you the two different ways on how to check if the sensing bulb has lost its charge or not, it is important to understand how the TXV and the sensing bulb works, and I'm just going to briefly go over it with the 4 different scenarios that I drew. But it is important to understand this. As you already know, this has refrigerant. The sensing bulb gets strapped or mounted on your suction line. And of course, it needs to be mounted 10 or 2 o'clock, depending on the manufacturer. It needs to be strapped and insulated. But based on how hot or cold the suction line is, that's gonna either open up to allow more refrigerant to go through on the TXV, or it's gonna pinch down to allow less to go through. So this sensing bulb here on your suction line, if your suction line starts to get warmer and warmer, it's gonna push and really increase the pressure because it has refrigerant, increase the pressure on the sensing bulb, and it goes connected to the head right here, and that's gonna push down to allow more refrigerant to go through. If maybe the house inside starts to get a little cooler, the suction line starts to get a little bit colder, the sensing bulb is going to be like, whoa, it's kind of cold. But of course, it does it by sensing the heat or the lack of heat on the suction line. So if it notices that the suction line is getting a little bit cooler, right, you're not going to have enough, it's not going to really react. That heat or lack of heat is not going to react with the refrigerant pressure inside. So then it's going to pinch upwards to allow less refrigerant to go through. So it's always trying to find that balance. So a TXV, it does about an 8 to 14 degrees of superheat, right? And so look at these 4 different scenarios that I drew. On these 3 right here, the TXV is working fine. The sensing bulb has not lost its charge. These are good. This one, however, the sensing bulb lost its charge, but we'll go over that one right now, okay? So TXV, 8 to 14 degrees superheat. It's trying to find that balance, right? So with this first scenario here, right? And I like to liken the sensing bulb to a guy who is just hungry with a big appetite. So you'll see why it differentiates here, but let's talk about this one real quick here. The sensing bulb is on my suction line and it's 52 degrees. It's not too hot. It's not too cold. How do we know that? Because my return air temperature is 75 degrees. I got 55 degrees coming out. So I got a delta T of 20 degrees. And my suction pressure is normal, right? Because my evaporator temperature is 40 degrees. But you see, there's a balance. It's the superheat. When you subtract 52 and 40, it's not 2. It's not 32. It's 12 degrees. It's trying to maintain that superheat of 8 to 14 because of the sensing bulb. Look how this example differentiates with this one right here. Look at this one right here. My return air in the house, now it's 70 degrees. It's still doing a delta T of 20, right? 70, and then 50 coming out of the supply. But now my suction pressure is a little bit lower. My evaporator temperature is 35 degrees. Why is that? Because my line, that's the key. It's important to understand my actual suction line, because the house is not hot, the line is cooler. So there's not a lot of heat that is reacting with the refrigerant in the sensing bulb. So there's not a lot of pressure pushing down to allow more liquid or more refrigerant through. Because there's less heat, there's less pressure. Because there's less heat, the guy here doesn't have the guy right here doesn't have an appetite. He's kind of full already. He's like, whoa, you know what? I'm kind of full. Just stop it with the food right now. Stop it with the food, right? Because he's not that hungry right now, right? It's kind of cold. The suction line is kind of cold. It's pinching down, allowing less to go through. But look how things change right here on this scenario. This one right here, right? The house, it's about 90 degrees. Everything is still doing still doing the same thing. You're still getting saturated refrigerant, but look at the difference here. 90 degrees and you got about 70 degrees coming out. And you're like, wait, that's too high. Nuh-uh, it's doing its job. It's doing the 20-degree delta T. 90 minus 70, that's 20. But my suction pressure is gonna be a little bit higher because we're throwing more refrigerant through the metering device, through the TXV. And why is that? Because my suction line is warmer. It's a hot house, it's 90 degrees. So this guy right here, he's like, hey, I'm really hungry. This suction line is really hot, it's getting warmer because the house is hot. I'm really hungry. Come on, give me more food, give me more food, give me more refrigerant. And that's what it's doing. And as you can see, my refrigerant, if you compare these two with this one, it's a lot longer down on the evaporator coil, but you're still able to maintain that superheat of 12 degrees. 62 minus 50 is 12 degrees. On this one here, because it wasn't that cold house, maybe the liquid refrigerant boiled off earlier, but it's still able to maintain the 12 degrees superheat because it's reacting with the sensing bulb. So once again, on a really hot house, that guy, he's like, I'm hungry, give me more food, give me more refrigerant, because that sensing bulb is noticing, whoa, this suction line is getting warm. So that heat is gonna react with that refrigerant inside, pushing downward on the TXV, allowing more refrigerant to go through. But one dead giveaway as to what's going on in the evaporator is by looking at your suction pressure. On this one here, your suction pressure is normal. On this one here, because there's not a lot of heat load, it's a lot less. On this one here, because there's a lot of heat load, your suction pressure is a lot higher, right? You have a 50-degree evaporator temperature. You're throwing more refrigerant on the evaporator side. The heat is reacting more with those vapor molecules. Your suction pressure is gonna be a little bit higher. Now, what about with this one? With the sensing bulb not working or lost its charge? Well, he had a stomach virus. His appetite, it's not working, right? So let's say the house is 85 degrees, right? And so coming out right here, you're like, wait, 75 degrees? I only have a delta T of 10? I'm not cooling. I am not cooling good enough. And the way you confirm it too is by looking at your superheat. Your suction pressure here, it can be a little bit confusing because it might be okay based on how hot or how cold the house is. But what you're looking at is your delta T and then your superheat. Because now on an 85-degree day, that guy is gonna be like, hey, give me more food. I need more food. Give me more refrigerant. But because he has a stomach virus or because the sensing bulb has lost its charge, there's no way to for that heat to react with the refrigerant to push more pressure to allow more liquid. We have a faulty, or the sensing bulb has lost its charge. The guy here, he lost a lot of weight. He has a stomach virus. Until that gets fixed, it's not gonna be able to react properly and find that balance. So in this case right here, looking at your superheat, looking at your delta T, that will kind of give you an idea, hey, my sensing bulb might have lost its charge. Now, of course, there are scenarios that we're not gonna go too much into it, but the sensing bulb might be okay, but there might be a restriction on the actual TXV. And so a lot of the times, and I kind of wrote it down right here, right? A lot of the times when there's a restriction, a lot of the times they have a strainer, maybe due to bad install practices, but that strainer gets clogged. And one good indication to know if it's your sensing bulb is okay, but this is restricted, a lot of the times it drops down fast. Your suction pressure goes down. I've seen it where it drops down to a vacuum, 0 PSI. In that case, then I could maybe just rule out the sensing bulb and maybe it is a restriction on the TXV. But now that we've gone over a couple scenarios, now I am going to show you two different ways that you can do when you're out in the field to check if the sensing bulb has lost its charge. Okay, so this is the first way, right? And let's just kind of have in mind where my suction pressure is at right now, right? We are at 165, okay? So we'll come back to that. We'll see where we're at after we're done here. But first thing is I get a cup with water and I fill it up with ice. Now, it doesn't have to necessarily be ice. It could be something that's cold, but it's gotta it's gotta make that water cold. It's gotta be cold. So you can go to your local 7-Eleven or anywhere where you can get ice for cheap. It's just a small bag, and then the rest of the ice you can get a nice drink that you can put ice on after you fix the service call with the sensing bulb that's lost its charge, right? But look, this is what we're gonna do. We have water here. I'm gonna put ice. I cannot just mix it a bit, okay? Okay, and then I have my my meter that I can, with the little sensor here, just to confirm that it's at least 32, or at least that it's just cold temperature. So right now, so let's just kind of mix that up. I have my little temperature sensor there. So let's go ahead and just get that probe here, okay? Okay, I'm gonna just put that probe all the way in there, and let's see what it's reading right now. 33 degrees. That's pretty good. That's pretty cold. Okay, you see, we can get it pretty cold, right? So 32 is good. Okay, so I know it's cold, so now I can just remove the temperature probe. And honestly, you don't even need to you don't need the temperature probe if you know that it's cold, right? I touch it, I know it's cold. This is a test though. This is what we're gonna do. I'm gonna put the water here. Okay, I'm gonna go ahead. Okay, keep an eye on that. Okay, it's 166. I'm gonna go ahead and get the sensing bulb, and you do have to. I already unstrapped it. You have to unmount it, right? But I already kind of took care of all that. I don't know if you can see right there, right? So I already loosened up the screw. I'm gonna go ahead and take it out. That's my sensing bulb. Okay. All right. Here's the test. This is how you know if your sensing bulb has lost its charge or not. What do you think is gonna happen when I put that sensing bulb inside that water, that cold water? What's going to happen to that suction pressure? It should start to drop down, and actually drop down pretty fast, because it's reacting with the heat or lack of heat. So here we go. I'm going to go ahead and dump it here. Okay, I'm going to dump it. I want you to look at the suction pressure. Okay, here we go. I'm going to dump it now. It's dumped. Look at that right there. It's dropping. It was at 167, 152, 142, 130, 120, 111, 106. That sensing bulb is working great. It has not lost its charge. But you see, 99 psi. It went from 167 to 99 psi. And all I did really was just dump it in there. That's all I did. Just dump it in there. Merge the sensing bulb in the cold water. And you're able to see, 92 psi. So yes, that sensing bulb has not lost its charge. If it would have lost its charge, a good indication would have been that the suction pressure would have stayed the same, or maybe have gone down very slightly, because it is possible that it loses a little bit of its charge, very little, and that could be hard to diagnose. But you see, with very cold water, it should go down pretty fast. So now it's picking up the heat from the ambient air. But that's the test. You have to get a cup of water and put some ice, make it really cold, anything that can make the water cold. Dump that sensing bulb inside your water, right? And keep an eye on where your pressure was, and then where it's at after you dump that sensing bulb in the cold water. And if it drops like you saw, then the sensing bulb has not lost its charge. It is reacting to heat or to the lack of heat. Okay, so the first way was putting the sensing bulb on something that is cold, so you can see the suction pressure drop. Now, the second way is putting that sensing bulb on something that is hot, so you can see the suction pressure go up to allow more refrigerant to go through. So right now, it is at 111, and it is going up. So think about it. What line here, or where here is it hot? Your liquid line, your suction line, your discharge line. Your discharge line is the hottest line. So what I do, let's go ahead and kind of get set up right here. I'll take the sensing bulb and I put I already put, let's see if you can see it. There's a zip tie there that you can see right there. You see the zip tie? And that line is hot. It kind of already burned me a bit. But what we're gonna do, and have in mind, of course, if the system is under charge, that discharge line might be too hot. So, you know, you're only gonna do this way just to make sure, you know, that the sensing bulb reacts. But if that line is too hot because it's under charge or, you know, other reasons, just be mindful of that, okay? So I know the system here is properly charged. Right now I'm at 130. So here we go. This is what we're gonna do. I'm gonna get the sensing bulb, okay? And put it, strap it right there. Let's see. Just give me 1 second here. Okay. All right, and then let's go ahead and get that sensing bulb. Okay, there we go. You see, I strapped that sensing bulb. It's not the best job, so what I'm gonna do, I'm gonna hold it. Okay, actually, let's just put the zip tie there. Okay, right there. So you see, the sensing bulb is not the prettiest, but it's strapped to this discharge line. It's picking up heat. I was at 130, right? And look, now I'm at 150 because that sensing bulb thinks, whoa, it's getting hot. That refrigerant is reacting with that heat that's in the sensing bulb. It's pushing downward to allow more refrigerant to go through. So this is another way that you can check. If you can, I know sometimes it's a little bit hard, but put in that sensing bulb by the discharge line so it can pick up some heat, or it can be maybe some type of other heat. This is probably not the best, putting it on top of the compressor. It is hot, but that's just another way you can do it. And you see, we already went all the way to 168, almost a 60-degree evaporator temperature. So I'm gonna go ahead and take that out, and I'm gonna go ahead and put that back right now on my suction line, right? So, but as you can see, these are two ways that you can check if the sensing bulb has lost its charge or not, by putting it in water that is cold. And if you put it on cold water that it's cold, and the sensing bulb, right, you put it inside and the suction pressure drops, it's doing its job. If it doesn't react, hey, it could be a sensing bulb could have lost its charge. If you put it where there's heat, right, like that sensing, the discharge line, your suction pressure should go up. If it doesn't react, then the sensing bulb could have lost its charge. Of course, the one way, and really the way that a lot of people do it, is with this, something cold, so you can see it drop. And where it can be a bit hard is when the sensing bulb lost a little bit of its charge, but it still has some charge. So, of course, by dumping it in cold water, you should see it react, especially if it's really cold. So things like these, guys, these are things that you definitely want to kind of have in mind when troubleshooting. The worst thing that can happen is replacing a TXV when it wasn't maybe a sensing bulb issue and it was something else. But just by doing these two different ways, at least specifically with the sensing bulb, it can save you a lot of time and headache. Friends, I really hope that today's video helped you out, and I'll catch you on the next one.